In this video, we're going to review the last 3 problems on the Computing Odds guided notes. Please have your notes out so you can follow along. Example: if you bet $5 on the number 13 in roulette, your probability of winning is 1 out of 38, but the payoff odds given by the casino are 35 to 1. So we need to find the actual odds against the outcome of 13. The odds against can be given by the probability of not winning divided by the probability of winning. We know that the probability of a win is 1 over 38. So the probability of not winning would be 37 out of 38, the complement. So we can fill in our formula. 37 divided by 38 divided by 1 over 38. Now, when we want to divide fractions, we copy the first, put a multiplication dot, and flip the second. The 38s will divide out, and we get the odds of 37 to 1. We can write that as 37 colon 1 as our actual odds against. For part B, we're asked how much net profit would you make if you win by betting $5 on the number 13. So, in this case, we're going to use the casino's odds of 35 to 1. That means that for every $1 I put down, I could win 35. So instead of putting down $1, I'm putting down $5. So I have to multiply that by 5. If I multiply one side of the odds by 5, I have to multiply the other side as well. So let's find 35 times 5. I get 175. So on a $5 bet, you would win 175. This is your winnings, not including your original $5 bet. The casino would actually give you $180, but your net winnings is still 175 because you paid $5 to play. For part C, we're asked if the casino were not operating for profit and the payoff odds were changed to match the actual odds against 13, how much would you win? Well, this time we're considering our answer from part A, 37 to 1. That means you could win 37 on each $1 bet. But we're putting down a $5 bet, so we'll multiply by 5. We'll also multiply our 37 by 5. And we'll get 185 this time. What you can see is that there is a $10 difference. For our next example, it says, suppose it costs $8 to roll a pair of dice. We get paid the sum of the numbers in dollars that appear on the dice. Is this a fair game? You need to think of the dice as 2 distinct different dice. So let's call one blue, the other yellow. Now we can fill in our table with the sums. If I roll a 1 and a 1, 1 plus 1 is 2. If I roll a 1 yellow and a 2 blue, I get 3. A 1 yellow and a 3 blue, I get 4, and so on. Pause the video and finish your table. We'll check in. You can see now that the numbers written in the table represent the sums if you roll the blue and yellow dice and get those numbers. So if I get a 5 yellow and a 4 blue, they meet at 9. The sum of 5 and 4 is 9. Now we're going to make a table where we have each sum x and the probability of getting that sum. So we can see that some of these occur more than once. So what I'm going to do is list the numbers x that appear as sums in the table. We see the sums 2 through 12. Now, 2 only occurs once out of the 36 numbers we have listed in boxes. There are 36 different combinations when you roll the 2 dice. So the probability of rolling a sum of 2 would be 1 out of 36. 3 occurs twice. So the probability of rolling a sum of 3 would be 2 out of 36. 4 occurs 3 times. So the probability of rolling a sum of 4 would be 3 out of 36. Pause the video and fill in all of your probabilities. Check your work on the completed table. Since we're trying to find the expected value, we're going to take each of our x values and multiply them by their probabilities. So we'll do 2 times 1 over 36, 3 times 2 over 36, and so on. Try this step and then check your answers. Pause the video. Check your x times p of x values. Now, we know to find our expected value, we need to find the sum of each x times the probability of x. That means we're finding the sum of everything in this column, the purple column we just created. Now you'll notice that I didn't write my answers reduced and that everything here has a denominator of 36. So what you can do is you can add up all of the numerators and then simply divide that sum by 36 to get your expected value. You'll come up with 252 divided by 36, and that's equal to 7. Now we need to determine if we have a fair game. Remember, our net winnings is our expected value minus our cost to play. Our expected value was 7. The cost to play the game is $8. So our net earnings will be negative $1. Since it's not 0, that means that it is not a fair game. So our answer is no, not a fair game. The last example has to do with money. Suppose you have 5 quarters, 5 dimes, 5 nickels, and 10 pennies in a box. One coin is selected at random. What's the expected value of the amount of money drawn from the bag or the box? Let's make a chart to represent our x values and the probability of those x values. So first I have 5 quarters. A quarter is worth 25 cents. There are 5 quarters out of 5, 10, 15, 25 items in the box. So the probability of drawing a quarter is 5 out of 25, or you could say 1/5. There are also 5 dimes in the box. A dime is worth 0.10. The probability of drawing a dime is 5 out of 25, or 1/5. Next we have nickels, which are worth 0.05. Since there's 5 nickels, the probability of drawing a nickel is 0.25, or 1/5 once again. And finally, we have 10 pennies. A penny is worth 0.01, and the probability of drawing a penny is 10 out of 25, or 2/5. We need to find the expected value. To do that, we're going to take each x value and multiply it by its probability. So we'll have 0.25 times 1/5. 0.25 times 1/5 equals 0.05. Next we'll have 0.10 times 1/5, which equals 0.02. Next we'll have 0.05 times 1/5, which equals 0.01. And finally we'll have 0.01 times 2/5, which equals 0.004. To get the expected value, we are going to find the sum of all of the numbers we got in this column. So the sum of our x's times their probabilities will be the sum of all these numbers right here. And we'll come up with 0.084, which is 8.4 cents. Or you can write it as $0.084. That's the expected value to be drawn from the bag. Now, can you get exactly 8.4 cents from the bag? No, because we don't have a fraction of a penny. That's why it's considered an expected value, or an average of sorts. You can also do this problem without making a table. you can simply list and use addition between. So we would have 0.25 times a fifth plus 0.10 times a fifth plus 0.05 times a fifth plus 0.01 times a fifth times 2/5, sorry. And then you'll add them together and you'll get the same answer, 0.084. Students seem to have better luck and organization using a table, but it is absolutely your choice what you want to do. I hope this was helpful. Please contact me if you have any questions.